This is part 17 of 8086 instruction set, and we will be continuing with string manipulation instructions. Suppose that we need to look up a pattern in a particular string. So for that we have a set of scan instructions which will scan the given string and look for the first match of the pattern which we are searching for. So what such instruction is? Scan string for byte or scan string at byte level. So for this instruction to work, the string that we are going to search in for the pattern, its byte should be pointed to by the extra segment destination index combination. Okay, so as shown here, here we have a string of length 4 bytes. So the individual entries or bytes are pointed to by or located to by the combination of these two addresses. Okay, and suppose that we are in search of the byte B, right, within the string. So how SCASB works is, the byte for which we are searching, it has to be put in AL register, and the string, if it is pointed to by this mechanism, if we issue SCASB, then for one execution of SCASB, what happens is the current byte which is being pointed to by ES and DI, right, it will be checked with the contents of AL, obviously by subtraction, and if it is equal, right, if the byte is equal to the one that we are having in AL, then the 0 flag will be set, otherwise 0 flag will be unset. So for a single execution of SCASB, the current byte pointed to by ES-DI combination will be taken and it will be subtracted from that stored in AL. This indicates the working of scan at byte level. So the current byte pointed to by ES and DI is taken, and AL, the byte current byte in AL is subtracted from that in ES DI. So if the bytes are equal, 0 flag will be set, otherwise 0 flag will be unset. And again, the string is composed of multiple bytes. So in order to compare or check the entire string for the pattern, we may need to advance DI byte by byte until the string length is exhausted. So the direction of incrementing DI or decrementing DI is determined by direction flag, as in case of most string instructions. So if direction flag is 0, what happens is this DI will be incremented towards the higher address range, so that the entire string may be covered in the forward direction. Okay, likewise the other case where DI will be decremented. Now, as we have seen, for single execution of SCASB, right, only a single byte is compared with the entry stored in AL. We may need to check the entire string for a suitable pattern. So until and unless we find a match, we have to go through the entire string. Okay, so we have to repeat SCASB when all the subtractions won't give a 0, or it means that still we don't get a match, we need to repeat SCASB. Okay, so we have to repeat while the individual bytes are not equal. So for that we need a repeat prefix instruction, and the instruction we have here is REPNE, that is repeat while not equal. So it is a perfect candidate for repeating SCASB, because as we are searching for a pattern within a string, until and unless we find a pattern, everything is a mismatch. So everything is not equal to the entry in AL, right? So while we are having an inequality, repeat SCASB until we find a required pattern. Okay, so that's the use of REPNE. So the maximum length of the string you can store in CX register, and while, as I told earlier, 0 flag is not set, this instruction, which is prefixed with REPNE, will be repeated again and again. Let's see how REPNE works. So REPNE is prefixed before an instruction, so here it is indicated as a chain instruction. And first REPNE checks whether the count is 0 or not. If count is not 0, what it does is it executes instruction to which it was prefixed, and it will decrement the count by 1, and it will check whether the 0 flag is set. If the 0 flag is not set, we have a not equality condition. So what REPNE does is it goes to this point or the entry point again, So it will again check for the counter value to be 0, and if it is not 0, we'll execute the chain instruction or the instruction to which it is prefixed once again. Then it will decrement the counter. Then it will check for the 0 flag, and if it is found to be unequal again, right, the operation due to the instruction has resulted in an inequality condition, then again it will go to its entry point and it repeats likewise. Suppose that if there was an equality condition at any point of this looping, right, within this line, what happens is this repeat sequence will be terminated and the rest of the instructions can be executed. Then there is another variant of scan string, right? We can scan a string at word level too. So what it does is it will take up a word stored in AX and compare with the word pointed to by extra sequence DI combination. So suppose here we need to search for the word AB within the string ABED. This is the setup. We need to put the search string in X, and then we need to make ES and DI point to the string, mostly to its base. Then we have to execute SCASW. Okay, so this is the working of SCASW. Here subtraction between the contents of ESDI and AX happens at word level, and 0 flag will be set or unset based on the equality condition. If there is a match in the first word itself, the single execution of SCASW will set 0 flag, right? And however, if we can't find a match in the first execution, we may need to further search the string. Okay, so we may need to move the pointer DI in either positive direction or negative direction. So that is again indicated by the direction flag. If you set direction flag as 0, what happens is DI will be incremented by a word count, that is by 2, towards the higher address range. Otherwise DI will be decremented. So this is an example of SCASW. So we are setting where the string is by loading the appropriate address values in ES and DI. So ES is loaded with the segment base, DI is also loaded with the offset to the string or the first byte of the string or the word of the string. And here we need to, with the length of the string is 16 words, so that is fed into CX. And we are moving the word that has to be searched for within the string to AX. Now we are clearing the direction flag so that the word that is the index, right, DI, will be incremented towards the positive side of the address. Then we are giving REPNE SCASW so that until a match is found within the string as pointed to by ES and DI, the SCASW instruction will be repeated, or till the string is exhausted.